Hello everyone, this video is meant to give you an introduction into static and dynamic firmware analysis for IoT devices. Really this lesson or video is meant to give you a quick introduction into firmware analysis for IoT devices. We'll talk about what static and dynamic analysis is, we'll talk about why we want to do firmware analysis and why it's important. We'll also try to examine some security related issues and bad practices that we typically find on IoT devices. Really the overall arching goal for this lesson is to give you some background into IoT device firmware, why it's important, and hopefully maybe get you excited about this type of analysis and maybe get you looking at your own smart devices that you have on your network to see if there's any vulnerabilities or insecurities that you might want to address. Our outcomes that we're trying to get to through this lesson in lab are to describe some bad practices found on IoT devices, compare and contrast static and dynamic analysis, actually trying to identify some of the security related issues by analyzing some sample firmware. We'll do that in the lab. And then we want to be able to use and list some tools that are available to help us do this. So first we should probably start off by talking about what an IoT device is anyways. I think we all probably have a decent idea in our head. We probably all have one of these in our home. Some quick ones that come to mind are like Google's Home Mini or Amazon's Alexa. Those are all IoT devices. There's also security cameras, smart home devices like outlets and light switches. There's a whole wide variety, and I have a list here. But really an IoT device is considered non-standard. So we're not talking about a laptop or a PC or a Mac or a Chromebook or something. We're talking about a device that has an embedded firmware or operating system. Maybe that's embedded Linux, and that's kind of what we'll focus on. And it has some way to interface with the device. So does it have a website that we can get on and interface with the device? Is there a physical button or screen on that actual device? We have to have some way in which we can use it. Most IoT devices are going to have some sort of embedded sensor. These sensors typically will send, collect, and exchange data. Most IoT devices are going to have some sort of network connection. Usually that's through Wi-Fi, it could be Ethernet, it could also be Bluetooth. But we're sending, exchanging data using that connection. So what is firmware? Firmware, I think the easiest way to think about it is the operating system for that IoT device. We know that an operating system is needed to interact with the hardware of a computer, and just like a computer, we need to be able to interact with the hardware and the sensors of an IoT device. So a little bit more formal definition of firmware is code running on hardware that is critical to the hardware's operation. It provides the necessary instructions on how the device is supposed to work, and it makes the IoT device work and do what the manufacturer intended it to do. So if they designed it to be a smart outlet and report out, what the voltage is and what the usage of that, the firmware is going to handle that for us. Many times firmwares will have updates, and these updates are typically pushed out to fix bugs or to roll out new features or improve security. This will be a topic of conversation coming up. But these firmware updates can happen automatically. Many devices allow you to choose that option to have the firmware be updated automatically, or it may need to be done manually, where you go out to the manufacturer's website, download the firmware file, push it out to the IoT device, and then potentially reboot it and have the new IoT firmware on that device. So where do we get the firmware from? If we want to analyze it, sometimes you have to actually dump it from the device's memory. I have a link out here which talks about some different ways in which we can go and extract firmware from the device itself. This is a little bit beyond the topic of this presentation, but it talks about a few different ways in which we're actually probably connecting to the hardware, and we are sort of scraping the firmware from that device. Probably an easier way, and what we will do is we'll download the firmware right from the manufacturer's website or FTP site. So I'll use D-Link for example. D-Link has a lot of IoT devices like security cameras and wireless routers and things. If I want to go grab firmware for a particular device, I can simply go out to their website, find the device, go to the support tab, and I can download the firmware. So we've probably done this before if we have some sort of smart home device on our network. So fairly easy to get firmware out there if we need to or want to. Another piece that's important that goes hand in hand with the firmware is the bootloader. The bootloader, in analyzing this, is again kind of beyond the scope of this presentation, but it's important to note here because the bootloader allows us to load the firmware, and when we analyze the firmware, we'll see references to the bootloader. So the bootloader runs before any operating system is loaded into memory, and it will usually contain several ways to boot the OS kernel, and it can contain commands for debugging and modifying the kernel environment. So if I can potentially control the bootloader, I can control the firmware that's going to be installed. Some common bootloaders out there are U-Boot, Redboot, Bearbox, and BusyBox, and we'll encounter BusyBox here a little bit when we do our lab. Why would we want to examine the firmware? Well, the firmware, like I said, is the operating system of that IoT device. And from an attacker's perspective, if we can control the firmware, we can control that device. We can use it as a pivot point or an entry point for a network if we were doing pen testing on that network. Many vulnerabilities are going to be found in IoT devices, and they're going to originate right within that firmware. So looking at the firmware allows you to peer in or look into how the device works and how it's configured. A lot of common mistakes in programming or setup are going to be repeated amongst manufacturers, and when you really start researching IoT devices, you'll find out that there's really not a whole lot of manufacturers out there. A lot of this stuff is just being rebranded, so you tend to find a lot of the same vulnerabilities from product to product. And as I mentioned here again, it can be an easy entry point for an attacker to enter the network. We've probably all heard of the example where the casino got attacked through the IoT device, the fish tank. They had a temperature sensor on the fish tank, which was connected to their network, and the attackers supposedly got into the network through the fish tank and stole money from the casino. So it's becoming increasingly popular to have these devices on your network, and attackers are aware of that, and they're starting to use those devices as an entry point. So what can I find when I start to analyze firmware? Potentially you can find some hard-coded values like credentials, so usernames, passwords. Maybe there's hard-coded encryption-decryption keys in there. Maybe there's network values, like what is the default IP address. So if I go and reset that device, do a factory reset, now maybe I know what the factory IP address is, and I can connect to it, potentially with default credentials. I can maybe see if encryption is not used for sensitive information. Maybe I find out that updates are not encrypted or updates are not verified. Now, why that would be important is if we know that updates aren't being encrypted or verified, I could easily intercept the update traffic for a device when it's attempting to go out and automatically update, push a rogue firmware to the device, and that rogue firmware would be something that I program myself, or I know that it has vulnerabilities, and now that it just makes it easier to compromise that device, gain access to it, maybe gain access to the network as a whole. So those are some of the things that we'll look for. So going hand in hand with what I can find when I look at firmware, there is OWASP out there. Maybe you're familiar with it, but they keep a list of top 10 IoT issues. This latest one is from 2018. I have a link here and also the graphic. But many of these are firmware related. So weak guessable or hard-coded password, insecure network services. An example of that might be like Telnet. That's insecure service. It's not using any encryption. Maybe SNMP below version 3. That's not using any authentication or passwords, those sorts of things. No encryption. That would be an insecure network service. So I won't read through all of these, but these are, again, some of the potential things that we can find and through our analysis with firmware. So that's why it's very important. So there's a couple different ways to do analysis of firmware, and those two different ways are static and dynamic. To make it simple, the easiest way to explain this is static analysis. The device is not up and running. You are looking at the file system, you are looking at the firmware while it's not in operation. So you can analyze the file system, you can inspect the bootloader, you can look for hard-coded items. There's a lot of tools that help with this. We can use things like Firmadyne, Binwalk, or Firmwalk, or those are just a few that I'm naming off here, and I'll demo in a bit. There's many different tools out there, but those are some of the more popular ones. Dynamic analysis, on the other hand, looks at the device and the firmware while it's in operation. So if you have a smart outlet, a smart plug, for example, it's actually on and connected to the network. With this, you're probably using more pen testing type tools like Nmap or Metasploit. So in order to do dynamic analysis, you actually physically have to have the device, or you need to be able to virtualize the device, which is what we will do with the device. Don't confuse automated static analysis with dynamic analysis. Automated static analysis is really kind of what we'll do in the lab, because we're going to use tools that will look for certain things for us. So we'll run scripts against the firmware to make our static analysis just a little bit easier. So using tools isn't necessarily dynamic analysis. Again, the big difference is static analysis is the device is not up and running, the firmware is not operational, where dynamic analysis it is. So how do we perform static analysis? This is not an all-inclusive list here. This is just kind of an example. But first we have to have the firmware, so we get the firmware. We'll extract the file system, maybe using something like Binwalk. And then we may need to uncompress the file system. We probably know that most IoT devices are pretty limited with their resources. And since they're limited with their resources in terms of storage and processing, a lot of the file systems are compressed. We need to uncompress or potentially unencrypt those too. Once we have the file system, we can look for common issues like we talked about, IPs and keys and passwords and those sorts of things. Then we can potentially look at the various binaries present in the firmware. We can check versions of those binaries to see if they have corresponding exploits, maybe in Metasploit or a different tool. And if we want to go a step further, this is kind of beyond the scope of our lab and presentation, but you can actually disassemble the binaries and using something like IDA or IDA Pro, and you can actually look at the code level to see if maybe there's some vulnerabilities or potential bad programming practices within that firmware. Dynamic analysis, on the other hand, we need to have the firmware running, so we need that physical device, or we can virtualize the device using something like QEMU. And that's what we will use in our lab, is this virtualization tool. It's actually a pretty cool tool that will allow you to virtualize almost any IoT device out there. Once you have the device virtualized, or you have the physical device up and running, you can use some pen testing tools like Nmap, Metasploit, TCP-dump, Netcat, or Wireshark to analyze the traffic. Remember, you can always use Google and Shodan to potentially find these devices on the internet. Maybe you'll find a Google dork or something. And then you can also find default credentials. So it's very easy to find default credentials for devices. If you know the make and the model of the device, typically a quick Google search will yield you the default credentials, and you can get onto the device that way. The focus of this presentation in the lab really will be static analysis. We'll do a tiny bit of dynamic analysis, but the tools mainly are meant to do static analysis. So some of the tools that are available to you, and this definitely is not an all-inclusive list, these are some of the more popular ones that I came across with my research, is Binwalk. Binwalk is a tool for searching a firmware image for embedded files and executable code. And I'll show some demos of these coming up. The next is Firmwalker, and Firmwalker is essentially a script for searching an extracted or mounted firmware, making your life a little easier as an analyst instead of having to go hunt and search for everything manually. Firmadyne is an automated system for performing emulation and dynamic analysis of Linux-based embedded firmware. Firmadyne is a little difficult to get installed and to use, so I ran across something called FAT, or Firmware Analysis Toolkit, which is really just a script to automate Firmadyne, and it will make your life much easier. So we'll utilize this in the lab. And then there's one other one here, which is known as the ERESI framework. ERESI stands for the E-Reverse Engineering Software Interface. It's pretty advanced. This is more on a programming level, on a binary level, actually disassembling the code. We won't use this one in the lab, but I thought I would mention it because if you really get into this, it's an excellent tool that you have available to you that you could use. So let's take a look at some of these tools individually. The first one, Binwalk. Binwalk is a great tool. So firmware, again, is a tool for searching a firmware image for embedded files and executable code. What it actually does is it looks for magic bytes within the code. Here's some examples of some magic bytes. And it reports on those magic bytes in terms of what is located, or excuse me, what is contained within that firmware. So in their own words, they said they sold out to the man. So there's actually a paid version called Binwalk Pro. It's a cloud-based firmware extraction engine, which will do a lot of these things through the command line automatically for you. Before I show it, I'll just talk about one other example using Binwalk. The Binwalk-E option, capital E I should say, because the lowercase e is the extraction option, is an entropy calculation. When you're doing firmware analysis, it's important to understand if that firmware is compressed or it's encrypted, because if it's compressed or it's encrypted, we need to deal with that first. So running a Binwalk-E can give you an idea if that device is encrypted or compressed, and then we have to, like I said, deal with that so we can actually analyze the device. If you've done any sort of malware analysis, you've probably run across this entropy calculation. It's just kind of a step to run to see what you work with that firmware device. So I have a Kali Linux distribution with all the tools that we need installed, and you'll see this on the lab sheet. To log in, it's root and tor. And just to give you a quick overview of this Linux distro, inside of the firmware folder on the top of the desktop here are all of the sample firmwares that we have available to us. You can also always go download your own. And then inside of the tools directory are all of the tools that we need to do our analysis. Now, Binwalk is installed by default on all Kali distros. So if you have a Kali distro of your own, you would not have to install this. But the basic syntax of this is Binwalk, and then you supply it the firmware. So again, my firmware is on the desktop. And just to show you, there they are again. The one we'll take a look at is this KKEPS. And this is actually Cancun or Cancun, I'm not quite sure how to pronounce it, smart outlet. Just show you here real quick within Google. So we're looking at firmware for one of these smart devices. Okay. So I type in Binwalk and I give it the firmware location. And again, what it's doing is looking for those magic bytes, and it outputs that it's an LZMA compressed, that the firmware is LZMA compressed, and that's running the squash file system. The next thing you'll typically do is you'll extract the file system. So Binwalk can do all of the extraction for us. So I add in the -lowercase e. And then what that will do for me is if I go look in my firmware folder, is it creates this folder with the extracted firmware. So now if I go into this, here's the squash file system root. Here's my Linux file system. So inside of here, I can start, kind of poking around. I can go inside of my, where would be a good place to look here? Let's go into etc. Let's go into the init-d. Oh, what do I know here? There's telnet. So maybe this thing's running telnet. Maybe I can go and look for password files or shadow files. I can start to do some static analysis of this file system and look to see if I can find any vulnerabilities. That kind of leads us to our next tool here, which is Firmwalker. Firmwalker is a nice little script that I ran across that will sort of automate looking through that extracted firmware for us. So here's the usage, and I'll show it here in just a minute. But it's going to go through and automatically look for all of these things: shadow files, password files, SSL directories, telnets. It's going to look for scripts. It's going to look for all of these things automatically for you. So it makes your life much easier. So let me just demo that here for you real quick. I need to move into my tools directory. Okay, so I'm inside of my tools and Firmwalker directory, and we have this firmwalker.sh. So all I need to do is run firmwalker.sh, and then I need to give it the location of my extracted file system root. So for me, that was inside of my firmware folder, and then it's the underscore kcaps extracted, and then inside of there I have the squash file system root. And then I can specify an output file if I want, or I can just hit enter and it will go to the standard output, which is the screen. So if I wanted to specify an output file, I could do that here. For now, I'll just output to the screen, but I can see all the different things that it's looking for. So starting at the bottom, it's searching for emails, searching for URLs, hard-coded IP addresses. It then goes and looks for OpenSSL, Telnet, BusyBox, all of these different things. It's looking through the file system and giving us some indication of maybe some potential vulnerabilities. And then if I see something in here, I can actually go into the file system and I can look at it further. So it found some indications of PWD inside of the etc init-d telnet. So maybe I want to go into that file where I just was and maybe do some more analysis. So again, excellent little tool here that will sort of automate some of our static analysis. Here's an example where I outputted it to a file. Essentially the same thing, but now maybe it makes it easier for me to search. I can Control F and do a find if I'm looking for something specific. So Binwalk to extract the file system, Firmwalker to look through it. The next tool is Firmadyne. Firmadyne is an automated and scalable system for performing emulation and dynamic analysis of Linux-based firmware. It does make use of Binwalk in the background for us and the QEMU virtualization engine. So it's going to extract the file system for us. It's going to virtualize the device. It's going to spin it up, and then we can interact with it dynamically. It can also perform these three basic automated analysis. It can look for accessible web pages. It can look for SNMP information, and will also do a vulnerability check for known vulnerabilities using exploits from Metasploit. Like I mentioned before, this is a little bit difficult to get installed and to use. So I did run across the Firmware Analysis Toolkit, which just makes it much easier. It's a script that allows us to automate the Firmadyne. And I'll just show that here in a minute, but essentially how you run it is you do a /fat.py inside of its directory, and then you give it the firmware file. So again, going out to my Kali machine, let me close this, and moving into my tools directory. If I take a look inside of the Firmware Analysis Toolkit directory, I can see I have that fat.py, and I also have this reset.py. The reset.py should be run before you analyze any firmware, just to clear things out because it stores things inside of a database. So I'll do the fat.py, and I'll do it against that same firmware that we looked at before for the smart outlet. So again, for me, that was in the desktop firmware KCAPS -3.5 bin. And when I hit enter here, what I'm going to see is it's extracting the firmware. So it's using Binwalk in the background. The next thing it does is it identifies the architecture. It builds a virtualized disk image using QEMU. And then it's going out and it's probing for the network connections. Like we talked about before, most IoT devices will use some sort of network connection, whether it's Wi-Fi or Bluetooth, and then it's going to simulate this. So I'll just give this a minute to figure out. One thing I did have to do with this is I had to up the timeout value in the script for this to 2 minutes versus 60 seconds. That seemed to help. Because not all IoT devices were able to recognize the network connections in those 60 seconds. So bumping that up seemed to alleviate all my issues. So if you download my pre-built Linux machine, it will have all of these settings and tools pre-configured for you. Okay, so I can see here now it was able to virtualize some of the interfaces. And now what I do is I hit enter. And what it's doing is it's spinning up, so to speak, that IoT device. It's virtualizing it. And the first thing that I'll do is I'll open up a web browser just to show you here because I know this exists. One of the IP addresses is 192.168.10.253. And here you can see now I'm on the web interface of that smart outlet. So now I'm interacting with it dynamically. If I go back to my shell here and I hit enter, I can actually see that I am on the command prompt of that device. So now that I'm on the command prompt of that smart outlet, I can start sifting through the file system and I can start interacting with it this way. I know the IP address of it. I could nmap it. I could run some other tools against it, and I could do some more dynamic analysis of it. So the Firmware Analysis Toolkit, again, which works with Binwalk and Firmadyne, is an excellent tool. Allows you to interact with that device. You don't have to now physically own the device. You don't have to go out and buy it. You can simply virtualize it. Last tool here, I kind of mentioned this already. This is a little bit more advanced, kind of beyond the scope of this presentation, but I thought I would mention it. So I won't go through all the details here, but if you want to explore it, you can just do a quick Google search for this. They have a GitHub and a website, and you can check that tool out. Again, what it's going to allow you to do is do some reverse engineering of the software of that device. So if you've discovered something, you want to test your findings. So maybe through your static analysis, you found out that Telnet is running, or maybe you found some hard-coded credentials. Well, you want to validate that. You want to make sure that that actually is something legit that you found. So using Firmadyne, using the Firmware Analysis Toolkit and that fat.py, you can now spin up that device and you can test your findings. So we want to verify what we found actually works. This will also give us the ability to notify our customers or our manufacturer potentially, or maybe we need to take that device off of our network. Again, the easiest way to do this is to virtualize the firmware, or we may need a physical device in some circumstances, maybe where the virtualization doesn't work or it needs certain internet certain network connections that we just cannot simulate. So with my last tool there, it actually started up the QEMU emulation of the IoT device. I just wanted to touch on this just a little bit more since we will be using it and it's available to us, and some of the lab is based around this. So what QEMU is, again, it's a virtualization machine for IoT devices. Actually, it can virtualize regular machines too, but that's typically what it's used for. It supports ARM or MIPS platforms, and those are just different platforms for different IoT devices. You can do a little bit more research on that on your own. So QEMU is very useful for testing and pen testing. You can see now that you don't have to have the physical device. You can virtualize it. You can use your pen testing tools against it once it's virtualized. So it allows you to take that firmware and really mount it and to get it active for some dynamic analysis. You don't need to purchase the hardware anymore. It really lowers the cost of entry into doing some IoT analysis. It's pretty sophisticated with how it works. I would suggest if you're just getting into it, use some of those pre-built scripts and tools that will automate a lot of this for you. So hopefully, as you can see going through this presentation and doing the lab and some of the demonstration, that firmware analysis of IoT devices isn't all that difficult to get started. The learning curve and doing some advanced analysis can ramp up pretty quickly, but to do some basic static or dynamic analysis really isn't that difficult. There's a lot of pre-built tools out there. There's a lot of paid-for tools that you can use as well. But again, it gives us a glimpse into some of the vulnerabilities that potentially exist on IoT devices. It gives us a glimpse into why attackers are looking for these devices. We talked about the OWASP top 10. Those are perfect examples of what we're looking for. We talked a little bit about static versus dynamic analysis and some of the different tools available to us. We talked about why we want to test our findings. And then finally, we talked about virtualizing the device. So again, really my goal in doing this presentation was hopefully just to give you a quick glimpse into IoT firmware analysis, give you a quick rundown on how it's done, show you some of the tools that are available in the lab. We'll expand upon this. You'll get to use some of the tools. You'll get to see some of the findings. And hopefully it maybe sparks your interest and you want to analyze some of the different IoT devices that you own and see, is this really something I should have on my network? Do I need to protect it further? Do I need to maybe change credentials or isolate it on my network? So I thank you for watching the video. I encourage you to do the lab that goes along with this to get some hands-on practice. And if you have any questions or run into issues, please feel free to reach out to me. Thanks for watching.